Welcome to the SciPhi Show, where we talk science and philosophy, usually with the brilliant atheist philosophers Alex Malpass and Dan Linford. But Alex can't make it today. However, we have a fantastic panel to review the digital physics argument for God from Mike Jones, also known as Inspiring Philosophy. And who better to review this argument than one of the very physicists actually quoted in Mike's video, Niayesh Afshordi. Niayesh is an award-winning astrophysicist and cosmologist at the University of Waterloo and the Perimeter Institute for Theoretical Physics. He's also my co-author on our book, Battle of the Big Bang, The New Tales of Our Cosmic Origins, which is released May 29th, and you can pre-order it now at most good booksellers. So welcome, Niayesh.
It's a pleasure to be here. Thank you.
And because this argument involves arguments from consciousness as well as physics, I thought, well, we've got to get Ken Williford on. Ken is an expert on the philosophy of consciousness and has developed a model of consciousness known as the PCM. He was until recently the philosophy department chair at the University of Texas, Arlington, and was also my co-author on a few papers we've written on the argument from animal suffering. So welcome, Ken.
Thanks for having me again.
So we're going to review clips that are taken from two videos in Mike Jones' Quantum God playlist. These videos have a huge number of views. And if you want to watch the whole videos, I'll provide a link in the description below. But let's see if they deserve the attention they've been getting and dive straight into the first clip, which is going to be about the Big Bang and VR.
This is the very question many philosophers and scientists have been asking lately. The data better fits the idea we are a virtual reality. Our world makes more sense if we look at it as a virtual world, and not an objective one existing independently. This established fact that space-time was created from a single event billions of years ago. Although hypotheticals have been proposed to get around this beginning point, the fact remains. Our universe, space-time, began to exist. From the view that our universe is all there is, as an objective independent reality, this makes no sense. How does space-time emerge from nothing? But if we look at the universe as a virtual reality, the Big Bang fits perfectly. Virtual worlds must begin with information influx from nothing. Brian Whitworth says, virtual reality theory fits well with the Big Bang. No virtual reality can have existed forever, since it needs a processor to start up. Every time one starts a computer game or boots up a computer, such a Big Bang occurs. From the perspective of the virtual world itself, the creation is always from nothing. As before the virtual world startup, there was indeed no time or space as defined by that world.
So, Niayesh, why don't we start with you? What do you think? Does this argument sound right? Does the Big Bang look like a VR?
Well, there seems to be some similarity. We have a saying in Farsi, we say, whatever is round is not necessarily a walnut. And I guess, yeah. So, yes, one thing may start and another thing may start. That doesn't mean that two things are the same things. I don't think it's a terribly complicated scientific argument to say that just because two things sound the same are the same thing.
Right. But any more specific differences you want to focus on?
Well, to be honest, yeah. I can get into the details that the Big Bang was not necessarily the beginning of time. It's just where our best models kind of stop making sense, and then we have a lot of models that are kind of less established that can go beyond the Big Bang. So either before the Big Bang, you could go either in loops, or you could have a bounce, or you could have all sorts of other weird stuff that are happening before the Big Bang. Or maybe universe did start at the Big Bang. But from there to saying that, universe must be virtual reality, I don't really know what to make of that.
Dan, what do you make of this?
Yeah, so I think, first of all, I agree that we have all of these other models in which the Big Bang is not the beginning of physical reality. But I think it's also important to notice why it was that it became or seemed to have become a scientific hypothesis that the Big Bang is the beginning of physical reality. Right? So if you go back to the 19th century and you said to someone living in the 19th century that, hey, there was this event in the past that was the beginning, do we have empirical or scientific access to that event? And the answer that you would probably get is no, that if you chop off time in any place, there's no reason why you would chop it off there as opposed to anywhere else. There's this very special feature in relativistic cosmological models in which those that include a beginning or singularity have this feature that if you try to extend space-time if you try to make space-time as large as it can possibly be, So if it's what's called maximally extended, then you can't extend it past the singularity. And that's an important feature of the classic Big Bang models that include a beginning. But notice that this also tells us something about simulations, right? So if I want to simulate the universe, well, I could start it at any time. I mean, it's kind of similar to what the person in the 19th century would have said. There's no reason to start it at the Big Bangs or as opposed to anywhere else. Anyone who's played around, there's a computer program called Universe Sandbox, in which you can put together these like crude simulations of astrophysical phenomena, and you can start them from any time that you want. You can set up a solar system and have it begin, have that solar system come into existence at the beginning of your simulation. There's no reason that you have to begin with a Big Bang. So if physical reality is, or what we ordinarily call physical reality, is some kind of simulation, I don't know why we would think that it would have to start with something like the Big Bang. We're like, that's an indication of a beginning if you have a certain kind of conception of the universe as a physical object that can be traced back as far as you can trace it. It's not the kind of start that a simulation has to have.
Ken, any thoughts on this similarity? Do you think it's compelling? We live in a VR simulation?
Well, I mean, I think the young Earth creationists can be happy because they can say, the simulation started 6,000 years ago, and it just looks like there was a big, you can trace it back, and it started with dinosaur bones already buried, and so I'm kidding, but
so there was a guy there was a theologian in the 19th century named Philip Ghost, I think was his name.
Yeah.
And who came with this hypothesis that he called Omphalos. That's right. And so the idea was that is exactly this: is that you can chop off the time at any point that you want, and then it's going to be arbitrary to chop it off. That it's going to come into existence with signs of some pre-existing state, even though there was no pre-existing state. And a simulation, it seems to me, has some of the same features.
Good, yeah. So, omphalos refers to, is the Greek word for belly button, if I remember. And
that's right.
The idea was, did Adam and Eve have belly buttons? And he argues, well, of course they would. Because, I guess you don't want Cain and Abel to be like, how come you don't have
I guess one thing I would add is that, saying that the universe is virtual reality is just kind of a bunch of words. The question is there a way to test it? If there is a testable prediction that would distinguish this from other alternatives, or maybe the more traditional way we think about the universe, or cosmologists like me think about the universe, then it's something that, okay, then I can go and test. But if you just call it virtual reality, I suppose you're free to call it whatever you want. And yeah, I imagine, it's coming with an idea that, okay, so maybe someone else is playing this game. But these are all stories. If as far as I can see, they are the same, then why are we talking about it?
Yeah. Actually, just a couple of things that sort of irked me a little bit. One, as you said, Niayesh, he said the beginning is an established fact. It's not. And then he says hypotheticals have been proposed to get around the beginning. But I don't think they're proposed to get around the beginning. Rather, because what cosmologists do is they try and push the envelope of our knowledge a bit further. So, take models like, let's take two examples, like string gas cosmology, loop quantum cosmology. What these guys did was say, well, let's get our theories of quantum gravity. We'll try and apply them to the Big Bang, and we'll see what they say. They're not trying to get it's as if they think cosmologists are really obsessed with a cosmological argument and trying to, defeat the second premise. But they're not doing anything like that. They're trying to do physics and trying to work out what happens. And then he says, but the fact, after he mentions that models have been proposed to get around them, which it's not what's happening. Then he says, but the fact remains that the universe has a beginning. Like, no, how did you establish that?
I guess there is a sense in which I would be inclined to say that physicists are trying to get around a certain kind of beginning, not for the reasons that he might think, but because if you look at the history of physics, whenever there's a singularity that appears in a theory or in a model, what has happen in every single case that we know of is that theory has been replaced by a successor theory in which the singularity did not appear. So the fact that Big Bang cosmology includes a singularity is a reason to think that theory isn't correct. And so there is some impetus to try to get around at least a singular beginning, but not because people are like trying to avoid God or something, but rather because of
But
how
also,
the history of science is proceeding.
You could have models with a beginning without a singularity. And
Yes,
they would also be as speculative as models without a beginning. You know, we don't know what's going on at the Big Bang. And for him to just sort of say, yeah, it's an established fact, just seems completely wrong to me.
Well, I guess maybe just to put it in the more historical context. So, I mean, science always has some kind of regime of a domain of validity where we could kind of study things well and then model them. And there's always a limit because of observations or just because of lack of imagination. We have always we always have a frontier, and then we kind of keep pushing the frontier. And for the past couple of millennia, that's been the case. And then historically, there always have been this God of the gaps. I said, okay, so maybe beyond this place where we understand there's God is running everything, and there are heavens that are really just because we didn't have a good theory of the cosmos, so God is running everything in the heavens. But the thing is, so this is another. So now gap is now at the Big Bang, and then they want to put something supernatural there. But I mean, historically, we always had these gaps, and we always pushed through them, and then there were no gaps anymore. Well, at least gaps are farther away now, and that's where the gap is right now.
And I guess I would just add one more thing, which is that I would be quite happy if, science can proceed in ways that are completely unexpected. And it could be that someday there's a testable hypothesis that involves a deity of some sort, and for reasons we can't see now. That wouldn't be a God of the gaps. That would be a case where one ought to invoke a deity to do some explanatory work in the sciences. Of course, that's not how science works right now, but maybe things could develop like that someday in the future. So it's not that we're not saying that his digital God hypothesis loses by default simply by invoking a deity. Rather, it's that, well, as we'll see, that there's many other reasons why his argument doesn't succeed.
Okay, so let's push on to the next bit of the argument where he's going to push this VR analogy again.
The fact that things like light are quantized as photons better fits the hypothesis that we are a virtual reality. In digital processing, all events and objects must have a minimal quantity that cannot be reduced anymore, and yet our world has the same effect. What about the fact that there is a maximum speed, the speed of light? Events in a virtual world must have a maximum rate limited by a finite processor, and our world has a maximum speed. Einstein deduced that nothing travels faster than light from the way the world works, but this does not explain why the world had to be that way. Why cannot an object's speed simply keep increasing? If light is like a classical wave, its speed should depend upon the elasticity and inertia of the medium it travels through. If light travels through the medium of empty space, its speed should depend upon the elasticity and inertia of space. However, how can empty space have properties? Virtual reality theory explains this, but objective reality cannot.
Niayesh, what do you think about this?
Well, I mean, it sounds like something from 19th century. I'm not sure it's this commentary, but I mean, so we have established physics now, which is, different from what you might have guessed intuitively from, like, I don't know, waves in the media. But I mean, relativity was born in, thanks to Einstein and others at the early 20th century. And we have theories that make this work. So, I mean, just because it doesn't match our old intuition or everyday life doesn't mean that it's wrong or it should be virtual reality. So yeah, I mean, I don't really know how to respond to this. It's just that it's counterintuitive, but we don't expect realms beyond our everyday experience to act exactly the same way that our everyday experience basically looks like. And that's basically the lesson of science throughout history, that the laws of the solar system was different from laws I shouldn't say this, different laws, but basically work in a different regime. And quantum mechanics is different and relativity is different. So whenever we push our laws into new regimes, we understand them better or you have to modify them. And that's what has happened. And yeah, I mean, I think this is just a process that has been very successful and it's part of science.
Dan, what are your thoughts?
Yeah, so I think the argument here seems to be something like this: that since the speed of light is finite, and you would expect the processing time in a simulation to be finite, therefore we should think that the speed of light being finite is evidence that we're in a simulation. But I don't think that anything like, I mean, I think that that's just completely, it makes a gross error, first of all, about philosophy of time. And the mistake that it makes about philosophy of time is the following. So there's two different clocks that I think we should be considering here. One is the programmer's clock, and the other is the clock within the program. Right? So anyone that's written a simulation knows about something called a time step, where you go from one instance of time being represented by the program to another. Now, how much time is between those two time steps? That's the programmer's clock, right? But if you're inside the simulation, you can't see the programmer's clock. So if you're inside the simulation, there's nothing that you can see around yourself that would indicate to you that some finite processing time is required. And in fact, I think it'd be quite easy to write a simulation where, from the perspective of, if you imagine little creatures within your simulation, from their perspective, a signal could propagate through the program instantaneously, right? I mean, how would you do that? You'd have some variable that represents some magnitude at one point, and you have some variable that represents the magnitude at some other point, and you just change both those variables at the same time. And because the programmer is not inside of the space-time of the program, they can do that all they want. So there's no the fact that a simulation has finite processing time doesn't tell you that that's what it would look like in perspective of someone inside of the program. And moreover, any instrumentation that we have has to always be, we have any of the instrumentation we have is limited. And that would be so even if signals propagated instantaneously, right? So they used to think back in, say, the 17th century that gravity propagated instantaneously, because that's what Newton describes it. But it was still the case that you couldn't measure something that happens completely instantaneously. There's always some precision with which you measure something. And given that level of precision with which you measure something, it's always going to be possible that a signal can propagate faster than your ability to measure, but still has some finite propagation speed. So I think both of those are reasons that this sort of gets completely wrong what it would look like if we were talking about the way that a simulation would work.
Ken, any thoughts on that? We're going to come to the consciousness stuff a little later. But,
no, that's good, because what you seem to be saying, Dan, then is he's presenting this as kind of like an argument of the best explanation. Like the best explanation of the limit on the speed of light is that we're in a simulation, right? And you're saying, well, no, because you could, in fact, you might expect the opposite.
Mm-hmm.
Is it? Am I following?
Yeah, well, I think it just doesn't give you any reason to expect it at all. You could build a simulation either way,
right?
And and it picks up like the wrong feature, right? So it's true of simulations that they have finite processing time. That's to calculate like the next time step. It's going to take some time, for example, but that has no consequences for what actually happens within the simulation.
Yeah. Good. Yeah.
Niayesh, any more thoughts? Can you maybe give us any indication? Why is the speed of light the limit? Is there some other reason that we could appeal to?
Yeah, I mean, this was the great insight that Einstein had back in early 20th century. That, I mean, all the other the waves usually are disturbances in media. And Maxwell in late 19th century realized that light are the waves or disturbances of electromagnetic field that propagate. And like other waves, it was expected that then it depends on the medium, because sound waves, their propagation depends on the medium. But it was surprising that the equations that kind of the Maxwell equations, unlike other wave equations, had this interesting symmetry that it looked like basically under the special type of transformation, they remained the same. So even observers moved, it looks like the speed of light didn't change. And then there was this big experiment by Michelson and Morley in, again, late 19th century that discovered that basically as Earth moves through the solar system, a speed of light, no matter which direction you kind of shoot the light, the speed is the same, and the interference patterns don't care whether basically light is moving perpendicular to the motion of the Earth or parallel to the motion of the Earth. So it looks like basically the speed of light didn't care. And that was kind of the big experimental reason that kind of eventually pushed this proposal of relativity. So that was, partly theoretical and partly experimental, but light is different, and it kind of unveiled this underlying structure of a space-time that suggests that time is not absolute, but rather time is relative, as is a space. But this combination of a space-time, it looks different to different observers, but somehow the speed of light is a fundamental property of it. And of course, this is something that may still not be a fundamental theory because relativity is still lacks a quantum description, and that's the frontier of physics right now. But it's that's what we learned, and from that was the beginning of relativity, and then later general relativity added. So Einstein added general relativity, which kind of included gravity, and has been basically arguably the most successful theory in the history of mankind. The theory of general relativity has been very successful. It's been tested all over the scale and time. So we have this very highly tested, highly successful, highly quantitative framework, which works. And then we have this idea that, okay, but it doesn't match our everyday experience, so or our intuition. So, I mean, I don't know. It's like saying that, okay, airplane flies, but I don't feel it should fly. But I mean, it does fly. So, there you go.
Actually, you talk about quantum gravity theories. There is, for example, Hodge-Lipschitz gravity, which would imply that the speed of light actually goes up and up to infinity as you approach the Big Bang. So it wouldn't be the case that the speed of light is a limit if that theory happened to be true.
Yeah, absolutely. I mean, relativity could have its own limits, and it may not be the fundamental theory. In fact, almost all physicists believe that relativity is not the fundamental theory of nature, because quantum mechanics needs to be integrated at some point. But I mean, I think we're kind of talking at different levels. That it is not because it's impossible. It's the reason is that, I mean, if you try to unite these two fundamental theories, quantum theory and relativity, you hit roadblocks, and then at some point, not in everyday life again, but at maybe fundamental level, you have to modify this. But again, that's a huge leap to saying that, okay, this looks like a computer because computers do this. I mean, computers are just kind of some element in everyday life that's, as far as we know, also use laws of relativity and quantum mechanics, and they don't really break them. So that's a much more, it's I guess I'm saying it's a much less powerful thing to say our world is like a virtual reality, because it doesn't have any predictive power. Relativity, on the other hand, has extremely powerful predictive powers, basically. So yeah. So I mean, it's kind of the trade-off. That is, you have this statement that doesn't make any predictive power, and you have the other statement, relativity, which has tremendous predictive power.
Mm-hmm.
Right. Okay. Right. So let's move on to the next clip, where actually they're going to reference your own work, Niayesh. So let's have a look.
In the hunt to rectify quantum mechanics with relativity, physicists discovered something known as the holographic principle, a theory which suggests the entire three-dimensional universe can be seen as two-dimensional information. In other words, the whole three-dimensional universe, the particles that make up reality, would emerge from underlying information in quantum field theory. The holographic principle only worked in theory at first, with no observable data to back it. But all that changed in 2017, when a peer-reviewed study published observable evidence for the holographic principle. They tested the model against cosmological observations of the early universe and found that the holographic model is compatible with the data that is found in the cosmic microwave background radiation. From looking at irregularities in the background radiation, their team found that simple equations of quantum field theory could explain almost all the cosmological observations, is marginally a better fit than the standard model, and could potentially explain apparent anomalies. But this would mean evidence in the cosmic microwave background radiation infers three-dimensional reality is an emergent informational construct. Observable evidence infers reality as we experience is not fundamental, but emerges from the quantum realm. What we think is objectively real is nothing more than an emergent construct of underlying mathematical informational processes.
So, Niayesh, tell us a little bit about your study. What do you think it leads us to believe?
Well, I mean, listening to this, I'm actually not sure if there's anything I specifically disagree with in what was mentioned, at least in this particular clip. But so basically, this comes down to the question of the very beginning. Can you come up with a good description of the early times? And so this is one of basically the fundamental questions in cosmology, especially early universe cosmology. And so this was actually originally proposed, or at least championed by Costas Skandaris, who is our co-author. He's a string theorist, and he suggested that basically maybe for the early universe, instead of coming up with some sort of a story, we come up with just a snapshot, basically, which doesn't have any time direction. So this holographic actually in the sense that you just get rid of time, and you come up with a theory that describes it's a snapshot that existed at the Big Bang, basically. It wasn't really that radical. It was just saying that, okay, so we have these models of inflation that was successful. Maybe you could describe it in terms of this, basically just get rid of the time and have a time-independent description of it. And then we kind of pushed it and said, maybe we just don't need inflation at all. Just essentially just imagine that universe started with a snapshot and we just come up with the rules of what that snapshot was doing or what universe looked like at that snapshot. So that was the idea. It's a proposal. And in some sense, you cannot really test it on its own, but unless you decide, okay, what are the rules at that snapshot? So we had some set of rules we assumed, which is kind of relatively simple. And that was consistent with data at least in some regime where we could make reliable predictions from the theory. So that's what it is. And I think it was amazing because it was different from other models and it worked reasonably well. But yeah, does it prove that holographic model is correct? I don't think so. It's not even a model, to be honest, by scientific standards. It's called holographic conjecture, which is basically this guess that quantum gravity is a universe which has quantum and gravity is dual to this basically surface at the boundary of our universe, which only has quantum mechanics. But it's not proven. It's not something you can prove because it depends on in physics you cannot really prove things. You can only test predictions. And there are always basically so many moving parts that it's almost impossible to test the predictions unless you kind of make a lot of assumptions. And in the framework that we did look at, it was okay. It was successful. But yeah, so I mean, at that level, I think it's a plausible model. But I think if you want to jump to being on a simulation from that, I don't really see any justification for it.
Right. Yeah. Actually, I've got a clip from Costas because I'm trying to make a film on holographic cosmology and I've already interviewed Costas. So I thought it would be fun to see what he has to say.
In my view, the universe existed forever. It is this timeless three-dimensional theory. It exists forever. What emerges, time emerges at some point. But beyond that, the universe is there forever. I'm getting a lot of messages from many people that they think that there's some consciousness behind it, and then or maybe metrics and everything. So holography somehow is meant to support these ideas. I do not see any connection myself. I do not see why you need any conscious being. So the emergence comes from interactions in this three-dimensional quantum system. That doesn't need consciousness to direct this.
Dan, any thoughts on this?
Yeah, I mean, I think it's so I have a few. I mean, one of them is just that what seems to be really what drives a lot of what this person does is that when he presents various versions of the digital physics argument, he is making use of an equivocation between two different uses of the term information. So sometimes when we use the word information, we mean, well, what we mean in everyday, something like what we mean in everyday life, where we're talking about like a message that I send from one person to another. And then it's, if you have that kind of thing, if you've got a message from some agent, then the existence of that message is evidence, well, that there is that agent. So it's, so if you had that kind of information about the universe, I mean, imagine this, imagine that you one day built a new instrument for detecting the cosmic microwave background, and you turn it on, and then you see a bunch of Hebrew letters spelled out across the sky. That would tell you something really maybe important about cosmology that'd be really profoundly unexpected, that maybe there is some kind of intelligent agency that produced at least the cosmic microwave background radiation. But when physicists talk about information, they don't mean it means, I mean, a more general concept than what we mean in our everyday lives. And because they mean something more general, it doesn't have to be the sort of thing that has to have some kind of intelligent agency behind it. This reminds me of a kind of a more general phenomenon where people get confused between or at least the way that I see it, is people get confused between the order of explanation. So they say, look, isn't the universe really orderly? Well, order is the kind of thing that we know that minds produce. Maybe there's a mind behind the universe. I think that gets the order of explanation backwards, because I think the reason why our minds like order is because we have the kinds of minds that are embedded within this broader ordered reality. And it's precisely because we are embedded within physical reality that we have to reason in accord with the reality that we live within. If you imagine a mind as some kind of agent that, I don't know, somehow outside of the universe, outside of the laws of physics altogether, and gives rise to them, I don't know why that entity would prefer order over anything else. It seems that it gets the order of explanation backwards from the way that it, the order in the way that it should be.
Yeah.
Right. Okay, so let's move on to. Oh, hang on. Before we do, I was just thinking about the sort of relevance of your study, and I was thinking, what was done. Tell me if I've got this right now, Niayesh. You've applied it to the CMB, and so far it looks good, right? But of course, there are several models, many models that have been applied to the CMB and have passed that test. So you have other models. For example, the one I think is fascinating is this periodic time cosmology, where the universe is on a loop, like literally cycling through time on a sort of closed time-like curve. And you applied that to the CMB and also survived that first hurdle. So that's good. That means, we're going up in our credence in these theories. But it's very far from saying, okay, this is now correct. It seems, I don't know, maybe going too far.
Yeah, absolutely. And I mean, like, the reason we believe in relativity as physicists is there's this preponderance of evidence from, say, from perihelion precession of Mercury to gravitational lensing to gravitational waves. There are, like, I don't know, literally, hundreds of experiments that test relativity to GPS we use every day, and they're all consistent with relativity. Just because you can have like one model that can explain one thing, that doesn't mean that model is correct. There could be tens of models that do that. But then you have to take that model and hypothesis and test it against many more scenarios in independent situations. And if it's successful in all of them, then you kind of believe in it as a theory. I just wanted to add something else. I think what Dan mentioned suggests something in my mind, that when we say zeros and ones, and physicists talk about that a lot in the context of holography, and when they talk about information, and when they say zeros and one, and everybody thinks, oh, maybe that means they mean computers. And I mean, I suppose, information is in computers. You can have information in computers, but you can have information in anything. And in this holography, in some sense, I mean, there is a sense that there is one version of holography where there is some quantum theory that happens at the boundary, and then that's equivalent to whatever happens inside. So, I mean, you can think of it as, I mean, if you think about that boundary theory as a computer, just call it a computer if you want, then that is, I mean, so that's a computer simulation if you want. But I mean, it's just a, I guess, matter of notation or terminology. I don't know if Ken did you want to say something about that?
Oh, just a more general reflection, which I think applies to the other clips we're going to see. I mean, there's kind of a long history of taking whatever is the current scientific view of something or whatever you think might be or whatever's promising for you and just kind of using it for your purpose and then kind of thinking you're done. But like I think of Lord Kelvin's arguments about the age of the Earth were pretty much in line with the science of his day. And then I can't remember the details, but
he thought the world was about 20 million years old because he didn't know anything about fusion.
Yeah. So, there's just this kind of tendency. So I wish that it would be one thing if they just presented these things as like, wow, maybe it's like that. That would be cool. Like, let's just have some, smoke a joint and get some wacky metaphysical ideas. And maybe they're, but to always present it like this is an established fact now. This is an established fact.
Yeah, that's the thing that winds me up. I mean, like, we cover a lot of speculative ideas, both on my YouTube channel and in our book, The Battle of the Big Bang, but we don't claim, that any of them are right. They're like, these are exciting ideas. Definitely get interested in them. But I don't think
you shouldn't like always be building your castle on the neck,
Right, exactly.
Because it might be sand.
Right, exactly. I think most of the ideas that we cover in our book are probably going to be wrong. The hope is one of them will be right, and that's what I'm excited about.
I mean, this really relates to this idea that I mentioned before, which is that he's confusing the way what a simulation looks like from the inside versus what it looks like from the outside. Mm-hmm. It's true that if you want to look at a simulation from the outside, if you can see what the computer is doing and so on, then you can see that it's a bunch of effectively ones and zeros, or a bunch of voltage levels or whatever. But if you're inside the simulation, then I can't see a single reason why you would have those bits necessarily available to you. I mean, the programmer could always ensure that whatever measurements the people within the simulation make, they always get whatever is the highest level of accuracy, highest level of precision relative to the instruments that those agents have so far constructed. And then there's no reason why you'd be able to detect the fact that you're inside a simulation, right? So it's really sort of this peculiar way of reasoning where he's not thinking hard enough about what it would really be like if you were inside a simulation. We simulate continuous phenomena all the time on the computer. And what you have to do is you have to make, like, for example, the time step small enough, the accuracy of each variable in the simulation high enough that it doesn't matter for the processes going on in the simulation, that it's ultimately discretized. So there's no reason at all that you would expect that someone within a simulation would be able to detect the discreteness of the world that they inhabit.
Right. Okay, let's move on. Oh, go on, Niayesh.
There is a way. You take the red pill.
Yeah. Okay, all right, let's move on.
The wave function explains the emergence of space-time, but the same underlying mathematics has been seen to parallel conscious thought processes. Quantum superpositions do have a vague similarity to how we think and mentally operate. For example, we often hold conflicting positions simultaneously before making a final decision, like how the wave function is in a superposition of multiple states before final collapse to one definite outcome. We can bounce around between different ideas in our head, similarly to quantum tunneling. In other words, there is a parallel distinction with the spaceless non-physical reality of Hilbert space, from which space-time emerges, to how the spaceless non-physical reality of our minds, our thoughts, emotions, dreams, is distinct from the external physical world. This is a common understanding with regards to the mind-matter distinction in philosophy of mind. No one can demonstrate how a mental phenomena would emerge from a physical substance. A feeling of pain can never be equated to an electrical signal. The mental experience of color cannot be equated to electromagnetic waves which hit receptors in our eyes. There is merely a correlation between the two, but one cannot explain how qualia could ever possibly emerge from this. As John Searle says, how does a mental reality, a world of consciousness, intentionality, and other mental phenomena fit into a world consisting entirely of physical particles and fields of force?
Ken, this is your area. Tell us what you think about this clip.
I mean, I wish I could. Am I being uncharitable in thinking that the argument is something like, look, here's some things that we're familiar with that seem like, kind of similar to quantum things, like superposition versus, deliberating about different options. And we can, the one about like bouncing around, like we can go from one idea. The first one I sort of get like what the analogy is supposed to be, but the second one I'm not so sure. But it just seems to me like kind of on grasping at straws a bit, or like it's just or whatever. Like it's not a very strong argument that consciousness is quantum somehow involves. It might, but like it's not a very strong argument. And then
there was a thing that he said. I can't remember what was the phrase. Something like, "No one can demonstrate how a mental phenomenon would emerge from a physical substance.
Yeah.
A feeling of pain can never be equated to an electrical signal."
Yeah,
but, people who are your theory is physicalist, right, Ken? Am I right?
It's neutral, but it could be physicalist.
Yeah, okay. But do physicalists think that they're just equating to each other these two things? I mean,
no, I think it's as if he has in mind kind of old school identity theory, like J.J.C. Smart and so in the 50s, and so where they would say things like, pain is C fibers firing, and it's like it's a very kind of crude way of thinking about, because I don't think there's anybody who's a physicalist in the philosophy, and I mean, by physicalists, I'm excluding the panpsychists who think they're physicalists too. But let's say a materialist, to use Joseph Levine's way of making that distinction. So if you're a materialist on his view, you don't think mind is fundamental. Okay, let's put it that way. Because the panpsychists will be like, well, we're physicalists, but we think like just the physical world is mental. Right? There's consciousness and so on. Anyway, so if we're excluding that kind of panpsychist, physical fundamentalist theories of consciousness, panpsychism being one of them, if we're excluding those, no materialist thinks that you should just sort of crudely identify a qualitative type with something as sort of simple as C fibers firing, So the view is that there's a whole lot more structure involved in being conscious. The qualia problem is sort of one aspect of the overall problem of consciousness, but at the end, you want a understanding of consciousness that includes its subjectivity, and its qualitative aspect, and also its representational aspects, and its unity and its temporality. So all of those phenomenological aspects, and it's just kind of strawmanish to be like, well, you can't equate qualities with, C fibers firing or wavelengths of light. Yeah, well, like nobody thinks that. Almost no. I mean, maybe you can find somebody, but almost almost nobody thinks things like that.
I think. Oh, go ahead.
Go on, Doug.
So it seems to me that so there's this very old idea that comes from David Hume, and what Hume points out is that if you're vague enough, then any two things are going to be analogous to one another, right? So the way that Hume ends up, the position he ends up with at the end of the dialogues concerning natural religion is that, if you have a vague enough analogy, then it's going to turn out that atheism and theism are not distinct positions. And it's going to turn out,
because
So the atheist might say, oh, there's this something or other that created the universe. And the theist says, oh, yes, there is something or other that created the universe. The theist wants to say that this thing has a mind. But then, the atheist will say, well, what do you mean a mind? Like a human mind? And the response is, no, it's something that has an analogy to a human mind. It's kind of vaguely maybe something like a human. It's like, well, it turns out that, basically any two things are going to be like this. If you're vague enough, if you're imprecise enough, then you're not really saying much by saying that, that by drawing an analogy. And I think that the same thing is going on here, right? So in quantum mechanics and in the study of consciousness, we have these two different domains in which they have this thing in common. The thing that they have in common is that in both of those areas, there's two different descriptions that we have a difficult time bringing together. In the study of the mind, you have the level of neurophysiology, and then you have the level of phenomenal consciousness. And there's this old question about how exactly those two fit together, and it's unclear how they do. And then in quantum mechanics, you have what you might call like the classical domain, and you have the quantum domain, and it's really unclear how those two are supposed to fit together. Of course, they're both descriptions of physical reality in some way, so they must be some way of bringing them together. And then the trick here is to say, oh, well, because those two areas both have two different levels of description, they must somehow be the same thing. And it's like, well, that can't be right. I know there's another clip. Actually, I don't know if it's included here or if it's in one of the videos that I watched of his, but so there's this literature in psychology, that's not really widely talked about, but there's, so here's a really widely known psychological fact that people make various kinds of systematic errors when reasoning about probability. And here's a fact that not a lot of people maybe know about, is that if you want to model those systematic errors that people make, it turns out that for a certain class of those systematic errors, some of the formal mathematical machinery that we use in quantum mechanics ends up being useful. That's a literature called quantum psychology. That's not the view that the mind is quantum mechanical. It's just the view that, oh, hey, look, like this bit of mathematics that happens to be useful here is also useful in this other place. You can't draw a metaphysical conclusion from that, right? I mean, that would be like, there's also places where there's mathematical models that are useful for modeling springs, that are also useful for modeling some financial situations. That doesn't mean that financial situations are made of springs.
They're made of springs. They reduce the springs.
Right.
So if I may add something, so I think just under physics, I think it's important to say that, I mean, these statements about the mind, they could just come from classical probability. I mean, there's nothing inherently quantum about it. Just the fact that there is uncertainty. If you throw a die, you don't know which is going to come 1, 2, 5, 6. They're equal probability. And that's just classical probability. There's nothing to do with quantum mechanics. So that, and also the fact that you could oscillate between one option and another, that's also can happen. A spring, if you try on it, it can oscillate back and forth.
It would take us really far afield to discuss, but what you described is like if you reason correctly about probability, right? And so the claim is that there's some errors that people make where they violate the Kolmogorov axioms in a sort of systematic and predictable way. And then if you want to create a mathematical model of the errors that people are making, of course, you can't use probability theory correctly when doing that because you're trying to model the errors people are making. And it turns out that for a particular class of errors, there's some machinery from quantum mechanics and that's what being useful. But anyway, I think what's the name there, quantum psychology, is going to cause a lot of people who for a long time have tried to make like these like new age connections between quantum mechanics and consciousness. They're going to latch onto that name and not realize that actually the claim being made is like super mundane.
Yeah. Well, and there's a lot of, right now, I mean, there's a lot of different approaches to consciousness involving various mathematical models. And of course, a lot of the mathematics, it's not unique to consciousness anyway. It's like, we're trying to find whatever tools we can to try to describe the phenomenological structure of consciousness. So you would want to mean, so if somebody uses mathematics from quantum mechanics to make sense of some, in this case, reasoning, reasoning, but there could be other things, like, there've been a number of, actually, there's been a lot of different proposals, not all of them sort of new age stuff, but a lot of them are, but like not all of them that involve quantum mechanics in one way. And I noticed, I don't think we're going to watch the clip, but in the longer movie, he's got Stuart Hameroff in there and microtubules, and then later he's got who else? It's another quantum consciousness person. I can't.
Well, we are going to play some clips with these. There'll be a brief mention of the microtubules. If you're quick, you will spot it. But we'll see. But one thing before we move on is the last quote from John Searle. I thought was a little bit dodgy because he had him, basically saying, "How does this is the quote from John Searle that he had. How does a mental reality, a world of consciousness, intentionality, another mental phenomena fit into a world consisting entirely of physical particles in fields of force?" But what he missed was the beginning of that sentence, which was, "The theory of the mind that I have attempted to develop is in large part an attempt to answer the question."
Yeah. Right. And he called his position, not very informatively, really, but biological naturalism.
Right.
Right. Searle thinks of himself. Is he still around? I can't remember.
He's still alive, I think.
He's still alive? Yeah, he's kind of.
I think so, yeah.
Kind of. Anyway, he described his position and thinks of it as some kind of physical, but not a kind of reductive physicalism or eliminativism, but like a realist kind of.
It's important in one other way too, in that the view of consciousness that this person's clips we're watching wants to present is one according to which like information processing is going to be very important. And Searle, of course, is someone who is kind of the opposite view about consciousness.
Right.
But for Searle, it's a biological phenomenon and not a computational phenomenon.
That's right. That is his view. I mean, he spent most of his career arguing, with the Chinese room argument and so on.
Right.
Arguing it's any kind of computationalist theory. And,
In fact, just to rub it home, I'll play a quick clip of John Searle describing his view of consciousness.
And I have only one real message in this lecture, and that is consciousness is a biological phenomenon like photosynthesis, digestion, mitosis. You know all the biological phenomena.
All right. So just in case you were doubting us. Right. Okay. So let's move to the next clip.
What if the problem is we think that mind arises from the brain, when in reality, what if the experience of the physical world arises from the mental world, correlating to how space-time emerges from Hilbert space? The correlates can no longer be ignored. The scientific evidence points to the fact that space-time and matter are emergent from the wave function in Hilbert space. In the inner world of consciousness and mind can be modeled as Hilbert space in the study of quantum cognition. Add on the evidence for quantum mind theory, and the most parsimonious explanation is space-time emerges from a shared inner mental world governed by a universal mind. The physical universe we experience is emergent from a necessary mind.
Actually, Niayesh, let me throw this over to you, because we do hear people working in holography say, space is emergent, or maybe space-time is emergent. What is it emergent from in the physicist's view?
So this would be some sort of fundamental theory. Often it's could be a string theory, or even something more fundamental, M theory, or there's just words people throw around. But the main thing is, one way to think about it, like we know about Newtonian mechanics, and it does emerge from quantum mechanics in some regime or from relativity in other regimes. So basically, there's just a more complete theory that we now discovered, or more complete theories that we now discovered, that the Newtonian mechanics of 1600s and 1700s can basically was an approximation to that. And basically, the idea is to continue that program and to say that, okay, now the theories that we have, quantum mechanics and relativity, which have this space-time in them, maybe there's a more fundamental description, and what we see as our best theories right now emerges from that more fundamental, and those are even better theories. which could address this inconsistency between quantum mechanics and general relativity. So what it emerges from, we don't know, but it's kind of a term that we say basically the fundamental kind of the language or degrees of freedom of this more fundamental theory may not be the same as what we talk about in our current theories. The same way that's, again, for example, in in Newtonian mechanics, we talk about trajectories of balls, but in quantum mechanics, we talk about wave functions, which are some description of probability, but they're not even probability. They are kind of more weird than probability. And yeah, so there's this change of language. Usually when physicists talk about emergence, they think that basically there are different degrees of freedom, different objects that we should be talking about when we transition to this more fundamental description of nature.
Right. Ken, what were your thoughts on this clip?
Well, I'm already thinking, like we've been here before. I mean, the quantum framing is new, relatively recent, but it just reminds me of like Bishop Berkeley and, the history of idealism. And, people would ask Berkeley, like, why do animals have insides? Like, why do we have brains if brains are somehow, are we like projecting our own brain into the physical world from some conscious space? That sounds very, very strange, So you kind of wonder why, if it's all, God is just imagining things, and is that what the story is? I mean, it gets like metaphysically weird very fast, and there's a long history of it. So if I would recommend that these folks study the history of idealism very carefully.
Well, I mean, I guess they have. I mean, they're promoting idealism, and they're trying to update it.
I think maybe for the sake of our audience, we should back up and say what exactly we mean by idealism. Of course, there's a bunch of different things that get called idealism in the history of philosophy, but here we have in mind, like Berkeley's idealism, where the idea is that what we ordinarily think of as the physical world is actually just whatever's in God's mind. And so we ordinarily think that there's matter as opposed to conscious stuff, but actually it turns out, according to Berkeley, there's this consciousness stuff. Ideas, right? That's right. Yeah. And so the reason why the question about the insides of animals comes up is that, well, if it's all just some construct in God's mind, why was it necessary for an animal to have an inside? And I think that even though, so that is a good objection to this argument that we should be paying very close attention to historical objections to idealism. At the same time, I think that there's also lessons, or maybe ways of explaining to philosophical audiences what exactly is going on in the quantum gravity literature that can make use of some of the ideas that we see in the history of idealism. So what's important about the history of idealism for physicists who are trying to get this idea across to philosophers is that it sounds very strange to say that there's something more fundamental than space and time. How could that possibly be? But actually, historically, if you look at the history of philosophy, there have been many philosophers who thought something like that. So Berkeley thought this, right? Berkeley thought that, he didn't think that it's the wave function, of course, that's more fundamental than space and time. But Berkeley thought that what's more fundamental than space and time is this big mind. And if you look at a figure like Leibniz, you find another view about how there could be something that's more fundamental than space and time. For Leibniz, it's everything is going to be reducible to what he calls the monads, and relations among the monads. And then what Berkeley had going on and what Leibniz had going on are sort of food for Ernst Mach in the 19th century. And then physicists will know about Mach because Mach was someone that Einstein read and drew upon when he was developing the theory of relativity. And we have, for example, Mach's principle from Mach. But there's this genealogy of the idea there that doesn't get discussed very often, but I think could help to sort of bridge the intellectual spaces of these two ideas together.
Ken, I mean, idealism's had a sort of popular revival recently, I guess.
Yeah. Idealism and panpsychism, which are distinct. I mean, but both of them are I like to call consciousness fundamentalisms, along with dualism. So any view according to which consciousness is, rock bottom fundamental thing. I mean, I think there's a really a kind of deep problem with the whole notion. At least it's worth reflecting on. It's basically, what is really the model of creation of the world here? Is it God? Is it like imagination? So God creates things by imagining them, and then does that actually make something concrete? And we have no real way of understanding. It really kind of breaks your mind if you try to understand it as creation ex nihilo. There's a great book on it by an old mentor or teacher of mine, Evan Fales, called Divine Intervention, which is a really good discussion of just like the very idea and the metaphysical problems with it. It's you might come away with the conclusion that it's really you can't make sense of it. It's kind of and in fact, for centuries, people thought the very idea of creation ex nihilo was nonsense. Sort of the Christians who made it more respectable in Western philosophy. But so there's this problem. Like, is it imagination? And notice that, like, to imagine something, you kind of already need some constraints. You already need some content to work with. Where do you get this? Where does God get it? So does that mean there are already like constraints and already like structures that God doesn't have control over?
This is sort of similar to the explanatory order problem that I raised earlier, that it's like, we have to reason in an ordered way because we live in an ordered world.
Yes.
But like, where do these constraints in God's mind come from?
So there's a great like history of this. So Pierre Bayle, who influenced Hume a lot in the dialogues concerning natural religion, has this great kind of dialectic of this issue, which is either you end up like with God has to obey these kind of constraints, and it's really the constraints that are sort of doing everything. Even Leibniz faced this problem because you said, God is intrinsically good, necessarily good, and so then God, and this is the best of all possible worlds. God has no choice about it. This is, then you kind of, God becomes just this kind of whatever this force is that's creating stuff and isn't really doing stuff by choice, which in Leibniz kind of said, no, he's inclined to do it, but he doesn't have to. And then it's like, okay, Leibniz, saving God's free will. So the kind of position that Bayle takes is that you have, if you're going to have really a God worthy of the name, God has to be absolutely unconstrained by anything, including logic. so
maybe I could add that I'm actually perfectly fine with we being God simulations in the mind of God, and then physicists and cosmologists, we are just trying to understand the rules that govern the mind of God. And by that virtue, we are the real theologians because we are the ones who are actually learning about God. All the other people who claim they know the religion, they are really false prophets. They're kind of making things up, but we are the real theologians. Yeah, there you go.
Right. So mind equals Hilbert space, and physicist equals theologians.
That's right. Yeah, physicists are the real theologians. Everyone else are the fake theologians.
They're simulations.
Yeah, there you go.
Right. Okay, so let's go on to the next clip.
It is completely impossible to describe the inner mental world in terms of physical interactions, but we can easily explain the physical world we experience in terms of qualia, shapes, forms, feelings, tastes, smells, etc. The physical world, it seems, is totally vacuous. No colors, sounds, smells, tastes, or sensations. What on earth is left? This correlates to what a few scientists have recently published, where they point out that there are interesting similarities between neural networks and the cosmic web of galaxies. Recently, astrophysicist Franco Vazza and neurosurgeon Alberto Folletti wrote an article on the similarities between both. Is the apparent similarity just a human tendency to perceive meaningful patterns in random data? Remarkably enough, the answer seems to be no. Statistical analysis shows these systems do indeed present quantitative similarities. They note the similarities line up with information processing, power spectrum analysis, total neuron to total observable galaxies, and in many other ways. If idealism is true, then this is readily explainable and fits with the rest of the data we have presented. Both form the same physical structure because both are emergent from an underlying mental reality. Under idealism, the brain is simply seen as the physical manifestation or second-person experience of a first-person conscious experience. And it fits with the idealist view that the whole universe would be structured in the same way, since it is also the emergent physical manifestation of mind.
So I thought this was actually where there's maybe the closest to making like a prediction, because they were saying, okay, so total neurons should equal total number of galaxies in the observable universe. And now this was written the paper, I think this essay came out in 2017. And just before, so there's about, Ken, if I got it right, it's something like 80, 90 billion neurons in a human mind, something like that.
Yeah, something like that. Yeah.
Right. And I guess they were saying, well, there's 100 billion galaxies. Wow.
This can't be, look.
But hang on, down. Here's the funny part, right? Because about the same time, I think it was slightly before, actually, 2016, a new study came out and said, no, wait a minute, it's 2 trillion galaxies. So wouldn't that actually falsify this idea?
Like, what about other brains?
Right. Yeah, like a cat has like 100 million neurons.
But
why not compare it to a cat?
So one of the reasons why this is this kind of complete nonsense is that it can't be a prediction of their model. Right? So if you go back, well, what was the model supposed to be? It was supposed to be that we're living inside of a simulation. And that this is why the speed of light is finite and why things are discrete and so on, because I guess they're like all these bits around us and everything. And now we learn, it's not that you're inside of a program. Yeah. It's that the universe is like made of neurons.
The brain. The God's brain.
Right. That's
yeah,
the wrong...
It's the idea that the whole, clusters of galaxies are basically God's brain. Is that?
It's the wrong picture, right? So there's this distinction in computer science between like the software level and the hardware level. And what where we started was by arguing that what we call the physical world is kind of like the universe's software.
Yeah.
But now it turns out that actually we can look around and see the hardware. That can't be right. Now, here's another really rather deep problem with this, is that so those structures that you see, now I don't know how to mathematically describe neurons or if this is the right way, that filamentary structure that galaxies form can be modeled as caustics. Now, caustics, if you go to a swimming, you look down into the water and you see all the patterns that from the rays of water going down through, and you see the pattern at the bottom of the pool. Those are caustics. So if that's the right idea, then what does that mean? Does it mean like when I go to a swimming pool that like I'm looking at a conscious thing? I mean, no. The other problem with this,
the universe is God's swimming pool, so that's
right. So another problem with this is that if you have a bunch of neurons, then maybe they form a brain, but they don't have to. I mean, you can just grow a bunch of neurons in a petri dish, right? And this is a problem that's sort of related to an issue that I have with panpsychism, right? So one way you can defend panpsychism is you can say, okay, maybe the intrinsic properties of any object are its phenomenal properties, its qualia. Mm-hmm. That's a view that many people have, even Bertrand Russell tried to present that as an argument. But now they try to say, the panpsychist says, okay, well, if all physical things have as their intrinsic features this qualitative aspect, then the whole universe is a mind, and that just doesn't follow. If it's true that there's like a mental aspect to like every physical object, it doesn't then follow from that the collection of all the physical objects form some uber mind. Yeah. Right? They don't have to compose in that sort of way. So even if you knew that like you could look out to the universe and see a bunch of neurons, the conclusion here just wouldn't follow from that.
The other thing I was thinking was that those galaxy structures didn't form till later on in the evolution of the universe. So did God become like conscious when these structures formed? And then what happens when they die out? Because they're not going to be there forever.
Right.
Or was the argument something like, I don't know, but like, because there's so many different kinds of patterns you can observe in nature. What, like, is any kind of pattern evidence for the quantum God hypothesis, or why just anyway? I don't know how to be charitable about this particular argument.
So this, of course, reminds me of when maybe kind of people find the face of Jesus on everything, like on various trees and various. But actually, I should add, Franco was, I think, we used to be friends on Facebook. I don't think he's not on Facebook anymore, but I remember he talking about this, and he, I guess it was an interesting thing. They noticed similarities in the statistical properties of galaxies and brain cells. And I mean, complex systems often do, kind of produce fractal patterns. I mean, this is the thing we kind of notice that like very, very various things, like different plants and, earthquakes. There are all sorts of kind of very complex nonlinear processes that are fractal patterns, like self-similar things that emerge out of them. And but then, I remember he was complaining that people were talking like, does this mean we live in a simulation? And he didn't anticipate this basically happening, but I was complaining that he had to now deal with all these crackpots. Yeah.
If it were true, like, why wouldn't we expect to see it in every structure we looked at? Like, because it's just mind everywhere. Why isn't it like,
and if
neuronal?
I think Niayesh has a really good point here, and that's that, what's going on is that you have some statistical pattern that's supposed to be in common between neurons and the network of the organization of the brain. Well, it turns out that one bit of mathematics is often useful for modeling many different systems that have basically nothing in common. So, for example, if you want to model the flow of a crowd into a room, it turns out that will have statistical properties in common with the flow of a liquid into a container. Now, does that mean either that a crowd of people is a liquid, or that a liquid is made of a crowd of people? Like, it doesn't.
Yeah, it's the second one.
It just doesn't, like, there's the conclusion doesn't follow. There's another example. There's a thing called a Bear-Bassi-Albert network. It's a kind of way that different, like a distribution of objects can be connected together, that it turns out to be ubiquitous. And so, for instance, if you look at the way that, airlines are connected together by like the planes that go between them, then you find out that forms what's called a Bear-Bassi-Albert network. One of the things that characterizes such a network is that you have these like nodes that have many, many links going into them. They're called those hubs. And so, of course, there's places like Chicago where like all the airplanes fly into it. Now, it also turns out that the network of, the citation network you find in a scientific community forms a Bear-Bassi-Albert network. Does that mean that scientists are airplanes? Like, right? Like, it's just, this idea is just preposterous, because if you try to apply it in other places, you find out that like the conclusion that you thought was going to follow just basically never follows.
Right. Okay, let's go to the final clip where he's going to he's put all the pieces together. He's going to lay out the argument. And I should remind people, these clips were taken from 2 different films, but they're all on the same, I think it's called the Quantum God playlist.
Formulate a simple argument. Premise 1. Simulations can only exist in a computer or in a mind. Premise 2. The universe is a simulation. This, of course, comes from the evidence presented earlier. Premise 3. A simulation on a computer still must be simulated in a mind. This would follow from the infinite regress problem if we were being simulated on a computer. To prevent the infinite regress of endless computer simulations, we eventually have to stop postulating higher levels of computers and stop with a simulation existing in a necessary mind. And we would also have to remember the importance of Occam's razor. If we have to inevitably arrive at the conclusion of existing in a mind, then why even postulate intermediate levels of computer simulations, unless it is necessary to do so? And no reason suggests this. And one can also argue that it may not even be possible to simulate conscious beings in a computer, given this hasn't been demonstrated to be possible, and one can argue that consciousness is more complex than just information processing. So Occam's razor shaves these off. But even if one insists on leaving them there, the universe would still exist in a mind anyway. So inevitably, we have to say premise 4. Therefore, the universe is a simulation in a mind. Premise 5. This mind is what we call God. And the conclusion simply follows.
Ken, why don't we start with you?
Well, why couldn't there be a necessary computer? I mean, if you got a God and you got why not just there's just the it gives a new meaning to motherboard, like the mother, the fundamental simulator thing. And again, this is sort of like, if you just kind of look at the history of this problem, you find it here it's recurring again, which is like you can't just automatically associate. So their whole argument about there would be a regress of computer simulations. What is it about a mind that makes it especially okay to be the necessary being, but not just like the eternal computer, whatever, churning out every possible simulation or something like that? So I don't see anything that a priori would make you favor the eternal mind. And then if we do end up with this necessary mind, we have this problem. Like, what exactly is it really God in the traditional sense? I mean, suppose it's all true and there's a mind that's just kind of imagining the world. In the video, the longer video, he mentions Donald Hoffman, and that I know those guys. I mean, they're basically Vedantists. They think, I mean, if I understand them correctly, they basically think that there's really just one consciousness, and you just kind of seem to be, just you, but you're, it's really, we're all one. Okay, and why does in Vedanta, why does God? Why the hell is anything happening? It's basically God just gets bored, it's like kind of an eternal play. And, they do have an interesting solution to the problem of evil,
Well, isn't that like Paul Draper has this theory? Well, not, I don't say theory, this idea. Dan, you studied under Paul Draper, so you can correct me if I get this wrong. That maybe what's going on is that the universe is really like a story that the creator wants to tell. And that's why we have evil, because, hey, we need drama in a story.
Yes,
and he's not good. The creator is not good. Rather, he just cares about a good story.
Well, but you can say, well, but you're doing all this to yourself.
So I think the idea that you're referring to is this idea that Paul has that, I mean, here's two different sets of values that a creator might have. A creator might be really concerned with moral value. That's what many traditional religions have maintained, at least Abrahamic religions. Or a creator could be really concerned not with moral value, but with aesthetic value. Suppose that they were some great artists and that they didn't give a damn about morality at all. That might give you an explanation for why there's so much suffering in our world that wouldn't make sense if you had a creator that was really concerned with moral value. But I think it's so a lot of what he's talking about here, that's supposed to be indications that something is a computer, are things that computers have that we're familiar with because those computers exist in a broader physical context. So, for instance, the fact that computers have finite processing power is due to the fact that the machines that we use to run that software have various physical limitations. The fact that they have to have discrete representations as opposed to continuous representations, again, has to do with the fact that the computers that we're familiar with have to be the kinds of machines that humans can build. If you imagine I don't even know how to imagine it, but like a computer that was somehow beyond the physical world, or the whole physical world is contained within this computer, it wouldn't have those kinds of constraints on it. And then I don't know what to expect from it. The other thing that sort of occurs to me here is that there's a sort of trivial way in which something like this might be true, but in which you wouldn't get any of these religiously relevant conclusions. So suppose it turned out that someday, and maybe someone's already done this, I don't know, but supposedly someone had the following kind of result. Suppose that someone took a hard look at the laws of physics and realized that the laws of physics are Turing complete. So that, and I guess maybe that's actually trivial because we can build computers in our physical reality. So I guess maybe they have to be Turing complete given that you could build a computer. But anyway, if the laws of physics are Turing complete, then there's a sense in which the entire physical world just is a computer because the entire physical world is capable of doing any computation that any Turing machine is capable of doing. And that has no religiously relevant conclusions, right? There's no religiously relevant consequences from that.
Yeah. I wonder if there isn't something going on where, if we asked hundreds of years ago, people might have said, or some people might have said, oh, the universe is like a clock.
Right.
And now we're hearing, oh, the universe is like a computer. And I'm wondering if whatever the next technology might be, it's going to be like that.
What's interesting to go along with that is that at each of those different stages of technological development, people have not only equated the most sophisticated machines to the universe, they've also equated the mind to the most sophisticated machines. And that may be the source of a kind of misleading analogy here. That there was once a time when people would have equated the universe to a clock, but in that same time, they equated the mind to a clock. So Leibniz compares the brain to like clockwork, and then of course
a mill in one passage, a big complicated mill.
Yeah.
Right. Okay. Any last thoughts, Niayesh, on that argument?
Yeah, I guess there are a couple of things that just comes to mind. This issue about the digitalness, I mean, it's a little bit of red herring because, I mean, we used to have analog computers and it just, and the reason we now have digital, in fact, this was a transition at like around turn of the century, basically, was that it was much easier to get rid of noise and basically correct the signal with digital signal as opposed to analog. I mean, the old communications was in analog, but there was always noise introduced, and the way to get rid of that was just to switch to digital. So I don't know if there's nothing fundamental about that. It's just the method that we use. And, I mean, the fact that the quantum world has some basically discreteness in it. I mean, I think that's completely separate. It has nothing to do with the fact that we use digital communication. I think there was, I suppose if I want to conclude all of this, I mean, I'm kind of perfectly fine at some level to saying that, okay, we live in the mind of God and this is a simulation. I mean, as far as I'm concerned, I don't see anything wrong with that. The only thing that's wrong is like someone comes tell me that I know what God actually God wants you to do. And I'm saying I'm the one who's studying the mind of God and have been, so how do you know what God wants me to do? That's really where the problem is. But I think it actually speaks to a need that, I mean, I think historically the way humans have been kind of making sense about the relationship with the world around them, God has been like an element of that relationship. And I mean, even if we understand our world better, we still have to decide how we want to relate to the world around us. I mean, science is not going to answer what I'm going to do. And that's been that's the role that God will probably keep playing, or whatever you call it, that we may understand the world better and better, but we still have to make a decision as to what we want to do with the world. And, so we have to kind of come to some conclusion as to how we want to make that decision.
Ken, final thoughts?
Oh, about this. I just think that, look, even if something like what they're suggesting is true, it's not clear that it has much religious relevance unless you are sort of inclined to, I mean, in the kind of Spinozistic sense, maybe, like, wow, that's really cool. But the sense in which it's a mind, like the kind of mind you could understand with intentions that you understand. I mean, this kind of goes back to Dan mentioning the closing of the dialogues concerning natural religion. Like, maybe it's somewhat similar to a mind in some way, but it's far, it's vaster. It has processes we don't really understand, and to ascribe intentions to it, and certainly to connect it with some particular revealed religion, that's way beyond what you're getting here. And
I mean, I guess this person inspiring philosophy, Mike Jones, he is a Christian. So I guess what he's trying to do here is sort of establish that there is a God. And then later on, I guess, with other arguments, he'll establish it's our God, So I guess that's the thinking. But obviously, this particular argument wouldn't do that.
But there's one last thing. I mean, there's also this problem I brought up earlier, which is about the constraints under which this world simulator or creator operates under, and the contents of its mind. Like, I can't imagine red, for example, if I haven't experienced it. I can't say, let there be red, or let and there be red. Like, my imagination is constrained by a lot of things, and both in terms of content, like what I can imagine, and the psychological processes involved. So it's if we take that analogy literally, then this God operates under constraints, and then if you bring in necessity and say it's a necessary being, it would seem like all of its properties are necessary in some way. And then you almost get like a kind of Spinozistic cosmos, like God, either this is this universe, if there's just one, is the necessary universe, and it must be, or there's a multiverse, and it's necessary. But it's like intention, desire, goals, that's all kind of out of the picture, it seems to me, at that point.
Dan, final thoughts?
Yeah, so I think I really like this point that Niayesh raised about analog computation. This is something that, the history of analog computation, just sort of independently, this is something that interests me anyway, but I think it's worth reflecting on why analog computation was given up. It was given up for a very practical reason, and that's that with a digital machine, you have error correction algorithms. With an analog machine, you don't have those. Back in the 1950s, when people were interested in getting really quick solutions to differential equations, because they wanted to calculate the trajectory of some object or something like that, analog computation was a really good way of doing that. But once you have digital computers whose accuracy outruns the errors that appear on analog machines, then it no longer makes practical sense to use analog machines. Now, if you imagine a computer of some kind that transcends the physical order, well, none of those practical limitations apply. Why would you expect it to be a digital machine as opposed to an analog one? And, analog machines, the ideal analog machine is actually capable of performing computations that a Turing machine can't perform. That turns out not to have any practical implications because, the size of errors that you get on analog machines prevents you from doing computations over the real numbers. But if you had a computer that transcended the physical world, if you had God's computer, as it were, why can't it do computations over the real numbers? And now I don't see any reason why you would expect it to be a digital machine as opposed to an analog one. It seems like maybe God would have some reason to use an analog machine. And I think that's a way of really nicely summarizing our complaint throughout. That the complaint that all three of us have had at various points has been that this seems like a hypothesis that doesn't really predict the things that it's claimed to predict. And it doesn't predict those things because it asks us to imagine something that the author of this hypothesis hasn't thought through carefully enough. And as I said at the very beginning, I don't think that if we were inside of a simulation that it would be necessarily easy for us to detect that. Unless the only way that I can imagine that you could detect it is if someday the programmer reaches down into our world and hands us the source code for the world that we live in, or if someday there's some mechanism by which we free ourselves from the simulation. Right? I mean, that's Niayesh brought up, taking the red pill. And what's nice about The Matrix, about that movie, is that there is this mechanism by which Neo discovers he's living in a simulation, not because he finds various empirical discoveries that suggest it, but because he gets taken outside of the Matrix.
Yeah.
That's right.
The red pill.
Actually, quick bit of movie trivia. The red pill thing was actually in the movie Total Recall before it was in The Matrix, which was based off a Philip K. Dick short story. We can remember it for you wholesale. And of course, it always annoys me that everyone goes, "Oh, like The Matrix," and I'm thinking, no, like Philip K. Dick. But what was I going to say? Yeah, I think maybe we could be living in a simulation. Maybe the simulator would put their initials in the cosmic microwave background. And when we look at the cosmic microwave background, we do see Stephen Hawking's initials. So I think Stephen Hawking is God. Anyway, we'll wrap up there. I hope you like this content. If you do, give us a like on YouTube, subscribe to the channel, and any thoughts, put them in the comments. We'll see you next time on the SciPhi Show, where we hopefully should have Philip Goff on the show, and we're going to be discussing his limited God hypothesis. So stay tuned for that. We'll see you next time on the SciPhi Show.